Thank you so much for being here. I'm truly honored. And just being a kind of a pulse in the room is cool because it's kind of a startup, large enterprise exposure. So I hope this conversation provides some inspiration, and I hope that some of the things that I'm seeing perhaps are patterns that you're seeing. But a little bit about me. So first of all, I call it the complexity machine kind of a hook for the title. TBD, we're going to be working on making it better. And today's conversation is truly a philosopher's take. I studied philosophy in my undergrad, but it's helped me a lot in my own professional career. So, my background's been like this. It's been quite random, but there's one thing that's quite stitching things together. My team, early 20s, I had a small business, my brother and my friend, we did primarily graphic design and photography. Over there, I learned that customers are important. Every single one of these different facets, I just learned something new more I got to pay attention to. I was in investment banking, I was part of the Groupon IPO, it was a very short stint. I realized that finance were important. I had no understanding of finance at that time. Then, became a K-12 teacher. I always appreciated philosophy and math and education, so I did that. And I realized that part of teaching, interactions were very important. Because the teachers that influenced me, I realized that never about the textbook is a way to get interactive with me. When I went to the Bay Area, this is where I found my passion for programming. I worked at a company called Famous. We built the first WebGL rendering engine in the browser. At first, we were doing everything with overloading CSS 3D transforms, where we're basically doing GPU accelerated interfaces. We have a fan in the back. Thank you. Over there, I realized we emphasized a lot about, as we were building this engine, my primary focus was lighting algorithms. How do I make this interaction far more realistic? And then number two, how do I make experiences far better for our end users? Did that for a few years, and I went to consulting where I worked at McKinsey, so I heard another McKinsey consulting, actually quite a bit of consultancy, which is awesome. And I learned here, scale is important. And now, I put entrepreneurship, I think a lot of the folks here, I'm trying to figure things out. It seems like I help all these things that are important, I'm trying to stitch it together for my next venture. And what that is, I'm building the community for WebGL and WebGPU. And if you're familiar with this, if not, there's a quick plug for this. WebGPU just became the default. It got enabled across all major browsers. So not only we get rendering, but we can do machine learning and compute in the browser. And there's a lot of investment going into this space. So if you're interested, I'm happy to share with you more of where I think the industry is going. So as I'm building the community here, I'm also iterating on what I believe should be the next form of interactive content. And it's still very experimental. So all of these, to me, is like, I realize that all the different professions that I'm going to, there's particular things that are important, and there's particular patterns that I'm seeing. And I'll put it this way. Some of you have probably worked with philosophers before, you probably hate them, but this is what we try to do. In math, or actually I would say most reductionist studies, we take something that's complex and we reduce it to a particular answer. In philosophy, we do the exact opposite. We take something simple, we just keep making it larger and larger and larger, and eventually we'll walk away. Right? I remember many conversations with my family, my friends, who would just stare at the wall and would argue whether the wall was white. And it went until 4 in the morning. This is what we do. But there is a benefit to it. Why? Because often I found that if you want to solve for a particular pattern at a general level, you have to take something simple and realize that this simple thing is not fulfillable across different contexts. So you start digging deeper into this. Like, hey, why does this thing is not, how do I come up with a solution that's more general across different contexts? So for example, what philosophers we do, somebody says, hey, this is not symmetric. And you're like, the idea of symmetry doesn't make sense in this other context. What is symmetry? What does it mean? Or this thing is good. But then you start realizing this idea of good has many different connotations in different contexts. So you're naturally trying to abstract and go up one level higher. So that the moment that you have a proper definition, perhaps it can fulfill in many different contexts. Right? And the beauty is when you put something like a philosopher, a mathematical approach, you first expand, you generalize, and then you figure out whether I can formalize a solution. So today's talk is something like that. I was in consulting and I kept hearing the word scale, scale, scale this, scale that. We need to reduce the complexity here and scale this particular thing. But what was weird is that there was not a proper definition of what scale meant. And this is my attempt of trying to formalize the idea of scale. And I'm not promising we're going to get to a simple beginning. I'm just going to take us over the hill where it's going to get very, very wide, but with one step of reducing the complexity. Does that make sense? And by the way, I speak very quickly. I'll try to slow down. I get excited and I speak very quickly. What would help me out if you have a question, if you want to interact, please just raise your hand. Alright, this is the agenda for today. I tried to make this more a story format than a traditional consulting deck, so hopefully it flows better. We start with the inspiration, we do a quick exercise together. We start the task exploring what the moment of scale, what does it mean in different contexts. Once we have that idea of scale, how do we reformulate the enterprise so that it can scale in practice? We do another exercise, we do some potential food for thought applications and some final thoughts. Inspiration, this is for Francesco. I shared the early version of this deck with him 2 days ago, and he's like, hey man, you should really add the inspirational story behind this. And I'm not sure if you all felt like this. Sometimes when you share your work with somebody and they give you feedback, I'm like, oh my god. And he was right. So thank you. So this is a call out to Francesco. This section is here because of him. And I got to do a plug for Mike on this. I came to Singapore about 4 weeks ago. I went to a lot of co-working spaces. This type of interaction that actually he gave me feedback and it's in the presentation is the value of this co-working spaces for me. So thank you, Michael, for putting this together. Thank you, Francesco. All right. How did this start? This is several years ago. We were building an airline from scratch, right? And we're not buying the actual airplane or any logistics. We were taking airplanes from a different company or building this thing from scratch. Now, this airline from scratch needs to be digitally enabled, meaning that all the channels need to be digitally enabled, and the airline wanted to expand a particular journey, meaning that the customers don't care about sitting on a plane buying a ticket. Nobody cares about that. You were trying to own the entire journey of understanding why does the customer want to go to this particular destination? Can we own that entire journey in there? Without getting too much into detail, but that was the ambition for this particular airline. And one of the challenges here, beyond the digital strategy, was this one key constraint, and it stayed with me for months, actually years after the project. It was still kind of in the back of my mind. I'm still keeping talking about it, so it's still not solved for me yet. But there's a moment of inspiration here for me. So this is a very, very simplified view of the architecture, but at the highest level you have channels, and in the context of an airline, it's web, mobile, aggregators, meta search, etc. Right? You have things from like Google Flights, Kayak, etc. You might have agency, web, mobile, corporate, many, many different channels, right? All of these channels need to interact with their core airline system. And in this context, you have maybe thousands and thousands of microservices, right? Simplifying. You have business capabilities, DAO, shared services, etc. The architect in the room would definitely know how complex that little piece is. What was also really interesting is all of these systems, the primary booking system of major airlines, are supported by 2 external partners, right? And what was crazy to me is that these underlying systems that pretty much power most airlines' booking flows, they have these contractual requirements. So in our airline, we're getting 100,000 requests per second with the ambition to grow across more channels. But down below, contractually, we're bound to 10,000 requests per second. And for the non-technical folks, imagine you have a store and you have this many people, 100,000 people wanting to come to your store at any given moment, but the door could only handle, let's just say, I'm saying 10,000, unless you have it truly 10,000 because it's very volatile, right? But the door can only allow a very, very small stuff that is people to come into your door. How do you solve for this? I'm curious for the folks in the room, right? There's a very typical solution here that we all kind of just reach into and we solve. So you have business requests coming in, but your underlying systems can only handle this much. Any general things that you've seen to solve for this?
Pay for 10 doors.
Yes. Actually, that is very much so what technologists we do, right? So, one here, in a technical context, we introduce a cache system, right? And what a cache system does is basically saying, hey, the last time we got this data, we stored this information in our own database for some period of time, so that the next time we require these requests that are coming in, whatever the requirement might be, we go to our cache. All the technical folks in this room know what a cache system is, and they've implemented in some shape or form, right? The challenge with this is that most cache systems across all these enterprises that I've seen, even in the startup that I was part of, right, there's lots of scale, more or less you have deterministic or some pseudo-probabilistic algorithms, or you have a fixed, most often it's just a fixed TTL. And a TTL is your time to live. How long do you want to store that item in your cache? So some organizations are storing it for an hour, some organizations are storing it for 24 hours, whatever it might be. And I think if you look at perhaps even the organizations that you're part of, you'll see a lot of cache systems with just a fixed TTL, right? And you have different algorithms that can help out as far as how long you store something for and what things should be evicted, but more or less quite simplistic. In the concept of an airline, when we introduced this cache, it became problematic. Why? Because as we increase how long we store the item for, on the other end, you would get stale data for your customer. So the customer will go through the entire flow, and at the end, the price has changed or is no longer available. You may have experienced this, right? And the challenge is that a lot of the aggregators and other folks, they don't even want to use your API. For example, your Kayak, Google Flights, etc., they don't want to use your API because if you cache it, they know they're going to get stale data. So they're trashing your entire system from a customer's perspective. They're scraping because they want to make sure they get proper information. Because they know that their API might have a different cache ETL than actually what your customers are seeing. And they're getting millions and millions of requests coming to your website, right? And by the way, for the folks that are not familiar with a cache system, there's an analogy that I think helps for me, but also drew inspiration. A cache system is also like, if you think about it like a grocery store. What's interesting about a grocery store is that it's much more, if you think about a grocery store in terms of the cache, it's far more intelligent. You have a whole bunch of produce coming in, and different produce have different life cycles. So the time that you store that produce in your particular store. So that the customer, instead of going down here and trying to get bananas, cucumbers, whatever you're getting, you're going to this cache. You go to the store that's storing it for you for some period of time. Now, if they store it for too long, the food, the produce might become rotten. You're not going to buy that. It's not valuable for you. If you store it too short, if it's not enough, you're going to go to the store and it's not there, and you have to go to the underlying system, wherever the bananas are, right? So what's interesting is that in the context of a grocery store, there's a much better, intelligent way of managing this ETL, how long you should store items for, right? When we went to the airline, this is crazy. We're getting more and more volume. All we're doing, we're distributing our cache cluster, we're sending them basically on different regions, but at the end of the day, our underlying system has this particular requirement. 10,000 requests per second, and anytime we went above it, it would be extremely expensive for the airline. Right? By the way, this is one of the biggest costs for the airline, is paying these underlying systems. Make sense so far, by the way?
Yes.
Any questions? Please. If anything's unclear, or if okay. All right. So as I mentioned here, on one end, you would increase how long you're storing an item for, but then it affects customers. You reduce it in your cost so that you can have better cost management and overall volatility of the system. But then you're getting a huge cost in terms of contractual agreements. And in some cases, you actually have another airline doing that. That's a different situation, but it did happen. Okay. So after a while, and I was in a fortunate position because I'm part of the digital strategy, the business case as well. And what happens when you have a large organization, you have engineers that are not tied closely to the business strategy, right? And to me, it's kind of a terrible situation because you have folks that are implementing a particular solution, and the complexity is rising. You build different types of clusters, different types of segmentations that they cache on, which is a very small technical piece of this large enterprise, but it has huge implications on business. So what I realized is like, hey, what is the actual business objective here? What if we formalize that? You would go to business and say, we need to always handle incoming traffic. Okay, if we always handle incoming traffic, you're going to get a particular scale. Is there a particular tolerance? Okay, which of your customers are actually your more high-value customers, medium and low tier? Which of the ones are actually most likely going to give you better margins? Which routes do you want to prioritize over other routes? Right? So these are very, very business language that anybody in the enterprise would understand, but it would not leak down to the implementation of the cache layer. Because the people that usually implement cache systems are not necessarily close to the actual business case and figuring out the tolerance of how much you should store an item for, whether you should admit it or not. So we just came with a simple abstraction. We said, all right, well, first I just went through a whole bunch of research papers, and there's plenty of them, that, hey, this is how long you should store an item for. We would just have a simple optimization that figure out dynamically whether cluster based on different types of users, different attributes, what is the right TTL value. We have plenty of literature here, right? But the challenge was, if you're optimizing how long something should be stored for, there's a whole bunch of other objectives. And the grocery store example was for me, very useful. Because in the grocery store, you have a fixed space. You there's a decision here on whether should you even bring something to the grocery store, whether you should add it to your cache before you decide how long you should store it for. And since you have a fixed amount of space, and the behavior of the airline is constantly changing, the traffic changes, there's also another one whether you should remove things. And sometimes these objectives are complementary, and sometimes they contradict one another. Right? So we realize that, hey, if you define this as a multi-objective optimization problem as a language of business, then you would have down here all the systems supporting you. We no longer need to work at the highest level of complexity of spending up more compute, different regions, figuring out how to spend more money in our overall cloud infrastructure. We just needed to expose this to business and provide them the levers on what they needed to. Does that make sense? This abstraction here was fundamentally lacking in the airline. Right? So this moment kind of stayed with me. We were trying to scale this airline, just in terms of traffic, how much is coming in. And we were at the lowest level of complexity, just throwing more compute, more money, and trying to solve a problem that in a way was overly complex. And as the airline was growing, we were expanding to different regions, it was getting unmanageable. Right? So this is where the inspiration came from. That's me in my shower, bath guard, towel, thinking about there must be something deeper. So I constantly keep seeing this thing. Scaling, aligning, reducing this complexity. And these things tend to be kind of correlated in some shape or form. So everyone was going, whether it was a startup, medium company, large enterprise, and it comes to an enterprise buying a startup and integrating into a larger ecosystem, this continually coming up. Same question. Again, the philosopher is like, hey, this idea of scale, what does it actually mean? Because it actually means different things in different contexts. So the situation here is that businesses are becoming more complex and the rate is actually accelerating. This is a force of nature, but it's also something that we have to be accustomed to. I'm saying this is not a temporary condition, it's a direction of the world. We're managing much larger supply chains. Our customers' demands are compounding, they're expecting more from us. The product cycles are compressing, etc. I think you've all witnessed this in your own experiences. And the complication is that you take the current situation, you extend it to the future, you realize that the complexity is only going to grow and it's going to become increasingly unmanageable. So we need a solution. All right. This is an exercise I want to kind of test this out, hopefully it works. In the space of design thinking, there's one of my favorite exercises, Crazy 8, where you try to come up with really absurd, crazy ideas, not meant to be judged, before you start thinking about proper solutions. And the value of this, I found, is that it helps have a much more elastic and creative way of thinking about things. So what I would love to do is that as you're thinking about this, we're going to break up for 5 minutes. For 2 minutes, you can break into groups of 4. By the way, this is inspired by Clarence. This exercise worked super well, so I'm taking that from him. If we just split into 4 groups, for 2 minutes, I want you to think about the most absurd, perhaps funny, paradoxical philosophical questions. Which one was your favorite? Just take a note of that, we're going to share that. And then the last 2 minutes, think of something very meaningful. And the point of this exercise is kind of to expand our way of thinking here to explore some absurd spaces as well, because I'm going to follow up with that. Right? So if you guys want to just break up into groups of 4 really quickly, for 2 minutes, think of the most absurd questions you can think of, and then we're going to stop, and then think of something brief.
No, I think that philosophy is very hard to do really. Most people don't have a good enough understanding. No, so maybe you come up with like really silly, absurd examples from meaningful, just like an experiment that we kind of open-ended question.
Oh, but it's Precedes.
To get to simplicity.
It
can be anything. I guess the point is that it really can be anything. That's what the point is.
It's so hard. I don't know.
See, what's absurd?
Yeah. Oh, so you can come up with lots of
It's just very basic, like paradoxes that are like not intuitively, deceptively sentient. I don't know, like if you are poor but you're happy versus someone who is rich but they're unhappy, who is the really wealthy? It's actually like not that complicated, but it's coming up a bit on the spot. You probably come up with all of these in the shower. It's just you're asked to come up with these answers. Like, or if someone is contextual versus someone who is in this room surrounded by people but sad, who's the lonely person? You can be lonely surrounded by people. Yeah. So those are the absurd ones, but then I think the meaningful ones are.
I mean, I was talking to my friend, and then there's this thing called time is not outside but within. So like the past is the memory, the future is expectation, the present is very attention. So how we experience time is like within our.
Yeah, it's I guess the meaningful example should be who has a lot of time, the person with a watch or the person who doesn't. Because one is bound for time and the other one is like perfect time. But they may not have a lot of time as well because they're necessarily
What time? What is time?
What's time?
Yeah, what is time? That's pretty meaningful.
Yeah, how we experience time. We are.
Time is experience.
Yes, because time dilates, right? It can short, it can expand or it can compress. When you're in stress, it tends to expand. That's why it feels very long when you're in an exam.
So if you don't experience time, does time pass?
Oh, that's eternity.
If you don't experience time, like it's just like if you don't hear the tree fall, it's a tree fall.
Let's try doing something with AI.
Yeah, sure.
AI.
But no one can explain. Huh?
I've been thinking about this a lot.
I love that. I just like the way you said it. I don't know that it's exactly like it explains like what.
But we have basically, I think that all of these LLMs, you basically have a guide to the library of Alexandria, all the knowledge of the universe. But does that make them an oracle? Can they actually, right? And it's oracle in the oracle of Delphi, right? Is that actually
Very interesting.
All right. Sorry, in the interest of time.
We have a picture.
Sorry guys to interrupt. I love the excitement. Just want to make sure I'm cognizant of your time as well. So we're going to go around really quickly. I would love to hear the table in the back. Well, a few questions that you were thinking about. Anyway, I heard definitely a few questions. Sorry, what was that?
Martin has the most controversial view.
We talked about like what is AI? Is AI like a problem? There's two kinds of problems. There's the Abrahamite Superman problem and the universal. There's also politically sort of heavily on problems that only have special forces and Marvel makes movies about it and stuff like that. And if you take this into a different space, this thing
I hope you have a good weekend. Any publishers? The group? You want me to continue? I want to make sure I don't go into like that. Good? Alright. So, this is exactly how I thought about the situation. I started thinking to myself, alright, what is this idea of scale? It's very important for us. What would that look like if I had to generalize this idea? So I went to a more mathematical way because mathematics tends to be a good language of generalization and formalization, right? But what was interesting for me is, if you look at it in a very primitive mathematical sense, the idea of scale is not actually what we need, right? Because this idea that, for example, in business or these enterprises or even the things that we're building, right? We want the output. If we add our teams together, whether we add technology together, whether we add features together, we actually don't want to equal the output of that technology. What's interesting is that because that's not what business wants. What business wants is a convex function, right? So in my mind, I'm like, okay, this idea of scale, right, and bringing this back to middle school, high school, that a plus b squared is greater than or equal to a squared plus b squared. So I'm like, okay, this idea of scale makes lots more sense. The intuitive sense here is closer to what business wants. That meaning that if you add things first and then scale, we get much more output, right? So I'm like, okay, this is interesting. We want to formalize that idea of scale this way. What does that look like? What is the function of addition, adding things together before you scale, right? If we can do that, that means we have a whole bunch of different tools that we could use to help us scale, to reduce the level of complexity of the model. So, again, this is just a formalization, very, very simple, but still, the philosophical question is, okay, we understand this mathematically, there are many different tools that we can use here to help us optimize. But what does it mean to actually add things together, and what does it mean to scale? And surprisingly, enterprises, if they're talking about the idea of scale, they're constantly adding, scaling, whether it's initiative, whether it's department, whether it's people, whether it's money. Actually, an enterprise, what you see is that the more that you're adding and scaling, you're actually getting sublinear results. And there's two classical laws that you might have probably experienced or heard of. One is, there's a product that's late, you add more people to it, and it gets even later. Which doesn't make any sense, right? But if you're in a sublinear context. Or Metcalfe's law. That communication scales exponentially, right? So it's interesting. Our idea of scale, we want linear scale, but in the context of enterprises, the traditional way that we scale, we get sublinear results at the top of the function, right? All right. This is a very known problem in organizational design and communication design. Is there a solution? So my first thing is this. I set up a Claude Code hook that tells me a joke after every commit. And my productivity has 10. I recommend it to you all. It's definitely a way we get fast that scale. This is actually a joke that I told me that I think possible, right? I definitely do more micro commits just to see what the next joke is, but I think it's a big incentive to get better commits. But all kidding aside, the question also came for me, like, okay, now I'm starting to traverse a much larger space. The idea of scale is, what is the organizational structure that we would want that allows for this convex scaling rather than linear, true linear, or sublinear? Right? That's the fundamental question. And by the way, this is the idea of Conway's law, that these organizations are a representation of the communication patterns of the organization. Right? And if you think about it, all these various organizational structures are trying to figure out, how do I get more, right, out of some of my inputs? That's fundamentally what they're trying to do. Because if that equation does not add up, it's better for us to all work independently. And I think Tony and I, how we connected on this very early in this topic, he's like, hey, we're just adding more and more resources in this context, but it's actually more incentivized these days to work as an independent solo, we're able to get more output. But that's not how we want to work on enterprises in the future, right? So if we just play this out, at the moment it seems that we can work faster at smaller teams or perhaps as solo entrepreneurs. That's great, but you're still looking for that convex function. At a certain point, if you want to become a larger organization, if it's useful, or if you want to get these super linear results, you have to scale. You're going to run into the same exact situation. So it's a very temporary solution where we're all working in small teams. Because what I noticed, at least in my consulting days, we were spinning up all these digital garages, smaller teams, smaller teams, smaller teams, but the complexity was being pushed onto the larger organization. The complexity is always there, right? So for a short period of time, you might get a quick burst, but you're still not solving this problem. And it felt to me the same exact situation was happening in the airline with the cash problem. We were getting these quick wins along the way, but at the end of the day, every time we were scaling, we were getting sublinear results, right? So, me myself, this is the reason why we go to that philosophical exercise. It's like, okay, if you try to apply a very, very simple mathematical model over the organization, which obviously overly simplistic, but it gives us a context. What would X, the enterprise, be in that context? What's the right way of looking at the enterprise? So, I thought to myself, what's interesting is, if you look at an enterprise as an abstraction to absorb complexity, a lot of these models will start to work. And what was interesting to me is that a lot of these, the clients or even myself, we're always trying to reduce complexity. But that's not actually the right way of looking at this. What a business is intended to do is to absorb complexity. And maybe perhaps a physicist would say that they're actually trying to bring in entropy locally at the cost of the global entropy. But that's what the point of an enterprise is to absorb complexity, not to reduce it. And the better that you can absorb the complexity, the better your business is. What that means, here's a story. So when I was thinking about this, I'm like, dude, what is fundamentally a business? I thought about this idea. Okay, we have a goal. I want to go eat dinner. And if there's no abstraction, the individual is exposed to the highest level of complexity, meaning that, okay, I'm hungry, I have to identify where to go hunt, I have to get all my tools, go out there, hunt if I know how to, bring the food back, cook it if I know how to cook, hopefully I know how to cook without finding some sort of poisonous result, and then I get rid of the waste. The user is exposed to the highest level of complexity. But then somebody comes along and says, hey, you know what? There's enough people that are introduced to this complexity that we can build an abstraction, which is the idea of a grocery store. The grocery store abstracts away supply chain and logistics so that now when I want to go eat dinner, I just go to the grocery store, everything is managed there for me in a way that I can trust. I buy, I go back, cook, and I eat. Then, there's enough that complexity, once that abstraction is there, that allows for a restaurant to come along. For people that don't want to get their food, but they also don't know how to cook, myself included, not only I'm absorbed away from the complexity of the logistics, but even the preparation of the food. So it allows for a restaurant. Then you start seeing more and more complexity happening. There's more and more restaurants popping up everywhere. But then some people, perhaps they're time-bound or location-bound, and they want to get food from different areas. This is an idea of UberEats, for example. Once you start realizing, hey, there's a little bit more complexity, more behavioral changes here, we can absorb that complexity out of a business model. So this is slowly becoming a little bit fruitful. And for the folks in the room that are maybe perhaps working with enterprise architecture, I realize that this is what enterprise architecture is intended to do. Enterprise architecture is not just software architecture, you have business architecture, process architecture, software architecture. They're trying to stitch together an area. And when they saw this, I'm like, hey, you're fundamentally having this as an abstraction, but what's happening in one department tends to get the primary view of the organization. Whether it's finances, whether it's product, but it's a singular view. You're not thinking about the abstraction level. So, this became helpful for me because I started realizing that hey, the structure of every business is about managing this complexity. And if you have this complexity properly managed, and by the way, there are a lot of frameworks and enterprise architecture to be used, but they're not necessarily intended this way. But once you have one mental model, teams, every single team, part of this structure can organize, if they can communicate, what is the complexity they're absorbing, for whom, and what cost, and for how long can they sustain this complexity. And this is the way I see it, right? On one end, a lot of enterprises, you have different individuals, different teams, different departments that are all pointing in different directions. And each one has a particular vector and a magnitude, a direction and a magnitude. And the magnitude is how much resources they have behind it, and the direction is what they believe the objective is. And often in organizations, these objectives are not actually formalized. Then you start having a whole bunch of meetings, artifacts, etc. You start having some form of alignment in the middle. But ultimately, what I'm saying is that with the right form of abstraction, with a singular objective, you can start properly aligning the organization with a singular objective. Kind of similarly what happened in the cache problem. The cache problem was not just a PTL problem, it was whether I should input something to my database, how long should I store it for, whether I should emit, and you can think about this at a much general level where the entire organization, all the departments, are oriented about a singular objective that's made up of a whole bunch of other objectives. So, and what's interesting is I spent many years in a strategy consulting firm, and I realized when I took this lens, strategy is only two things. The current abstraction, once you map that out, are you trying to optimize the abstraction? Means that are you trying to reduce the cost of that abstraction? Or are you trying to scale the abstraction scope? It's literally that simple, right? And what does it mean here by extracting away? A lot of the modern enterprises now, for example, I mentioned about the airline, but it's not just the airline. It's in mining, it's in construction. The airline realized that before they were owning a small abstraction of their journey, which is basically buying their ticket. But now airlines realizing that nobody cares about being out. So perhaps you can own the person leaves their home to go to the airport. What are all the services that they need there? What's after the flight? Hey, I'm flying to Spain. I like soccer. Hey, you want to watch Barcelona tonight? Rather than attention, so this is where a lot of the new organizations are trying to expand the abstraction space of what they're holding. And the idea is that if you do this technologically well, you can expand and then optimize. So there's this natural balance between optimization of the current abstraction versus expansion. Does that make sense, by the way? And to me, it was a cool moment for me because so many years working with strategy, there's all different strategical frameworks. I realized that it really comes down, you can build out a tree that all your strategies are either on one hand or this other end. And then you have your technologists, your designers, your product folks, your finance folks, all fall into one of these categories. So, now when I look at all of these different diagrams, on one hand you have your business capabilities map. This is very common across digital enterprises or enterprise architecture. Okay, here's our map and here's all the business capabilities that we're going to do as a business. Over here you have PPM, so you have like business process. Over here you have your hierarchy of people. So you have all these different slices that are pointing to something fundamental, but we're not seeing it. There is a fundamental abstraction, and each of these are different slices of that abstraction. What is the complexity you're owning, for whom, and what will cost. And here's the critical part. This is like very, very intuitive. I mentioned earlier that addition and scaling, well, we're not talking about addition, because we don't know necessarily what it means to align things, add things together in the context of an enterprise, right? It's not a simple addition operator. So you generalize. You say that there is a function out there. This function is about alignment. And it's alignment, there could be many, many functions that can fill that space, but it's not a simple addition. It could be an average, right? It could be just averaging a whole bunch of things together into a singular value, they say that's alignment. Perhaps if it's thinking about terms of vectors, how aligned the vectors are. But there is a function out there that can help us understand what does it mean for alignment, and there's a function out there that means execution. And what I'm saying is that the order of operations matter. First you align, and then you execute. Because we notice in the contact space, it's for the Mac folks in the room, you might see that this resembles, it's a much more generalized form of it, well, Jensen's inequality. And Jensen's inequality is such that the average of the function versus the function of the averages yields different outputs. In this context, I'm just generalizing the idea of alignment and execution, which means that if you align first and execute, you get a lot more than executing first and then align, because you want superlinear. And There's a right frequency. This is a problem that we see in large organizations. They're often over-communicating or overly producing a lot of artifacts. There's a natural balance here, figuring out what is the right group of alignment. Last exercise for this is I've been thinking a lot about this, and this is a genuine philosophical question. So I mentioned this idea that A plus B, first you add and then you scale, you get much more than scaling things independently. What I would love for the group to think about, given your experience, what does it mean for alignment? So it's basically two questions here. We're not going to talk about execution today, but think about, in your experience, when you felt aligned, when you felt misaligned, what were the things that were done? First, I would love for you to think about that concrete example in your mind. And then second, once you have that, is there some mathematical operation that represents that? But the first was more important. So let's for us to kind of break out into the same group and just think about, reflect on this idea, knowing that alignment is very important for execution. What does it mean to actually align in an organization? So let's just say, I've been thinking a lot about this in terms of from a physics perspective, as vectors, and figuring out some sort of cosine similarity between these, right? But it's not necessarily the right way. So I'm trying to figure out, what does it mean? What does it mean to align people, departments, projects? You can go at the lowest level to the highest level. So let's we can just think through this and come back with what you believe is alignment. I think it's the last group. You got that? No?
All right. So I hope that at least showing this idea that we want convex interaction, right? Because we don't want, or independently, we can actually get better results. The idea of scaling, we believe that we can get better scaling through some form of alignment.
And I hope that it's inspired this idea that alignment is critical. If you can figure it out, you can truly have a competitive edge over other enterprises. If you just think in terms of economics. These next slides I'm going to go kind of quickly because I want to get to the final point. This is an AI lab. The idea of abstraction fundamentally is just, if you look at it as a whole, it's the value that abstraction captures minus the cost of the abstraction. And this is not just a revenue minus cost model. That's just one of the lenses. That's the financial view of an organization. But there's many different dimensions that this function. At the moment, generally what happens in organizations, they just think of just the numerical value, the revenue minus cost. And what I'm pushing for is that there's a function here, and this function has many different inputs. And the better you can integrate this, the better of abstraction you can absorb for your customers. And again, I have a little derivation here. It goes into Josh Schwartz, and Ken's really important, but that's kind of important. I thought last night it was going to be important, but it's not. I'll put it here. So let's go back to the airline. A recall of the journey. In the airline wanted to scale in the highest level of complexity. The natural solution was to just deploy more compute, more cache, distributed cache clusters, etc. But we just realized that we're getting sublinear results. Basically, with a different level of abstraction that's closer to the objective. Once we formalize that abstraction becomes objective, we allow for the systems underneath to manage that process. Then, it seems to be a pattern across all systems that we want to scale. And what I'm pushing for is that I believe that there's a structure here that we can formalize to allow for us to get to the next level of complexity. How much more we can store for our customers and us. And depending on which level you take, obviously the journey continues to unfold.
One test I do want to add before I get into this idea, this is just a very general framework, is that questions that you should be asking about your abstraction. And what's interesting is that whether in consulting, whether in startups, large I didn't share this slide with you. Well, one that I find is completely underutilized is the Simon working mapping. I love this one. But Simon tends to push this thing for the broader context. I'm saying that it's only one slice of abstraction. But it is very useful. All right. So bringing this back, why is this even important? So on one context, I'm mentioning that, hey, if you're able to manage this complexity intelligently, you're able to have a competitive advantage. But what's interesting is, remember that the slide that I showed? No, not for the I'll show it. What I noticed, especially right now, I think you all might be feeling this as well. Imagine we're somewhere in this domain. And what I noticed is that we have organizations dumping tons of money in automation and AI. They're locally optimizing at the cost of the global context. So what's happening is that if you have all this misalignment and then you start bringing more efficiency, what you're doing, you're scaling that vector at the cost of the whole. And we already noticed here, the output of the organization is the sum of all the vectors together. So if you have one particular entity that's potentially misaligned with the rest of the organization, and you scale that magnitude, the output of the whole organization can be less. Right? So what I'm saying here with AI is our attempt to have more productivity and to be able to get to one level of traction higher. But what's weird is that we haven't figured out alignment yet. Right? So my push is that if we figure out this abstraction model with the right formalization technique, not only do we can have proper human coordination, but when we inject agents for machine learning optimization problems, they're all oriented around the same objectives. And then I'm thinking about myself that you have an objective, you have a series of actions, some of these actions are automatable, some things are manual, and you have constraints. And if you build this graph structure of your organization, then you can properly say that we have productivity and we can get to the next level of abstraction. That we can absorb more complexity in the organization. And I think the enterprises that are able to do this, everybody else is saying that super sublinear results, these organizations are going to break past that complexity. And at the moment, this is the only way that I see this happening. And last but not least, businesses are abstractions that are meant to absorb complexity. If you model that abstraction, that abstraction is trivial, your business is trivial. And if you're absorbing something that's meaningful, that's truly at the moment works at the scale. And that's the end of the presentation.
We open the floor for
Yes, of course.
any questions?
Yeah, I would love to get your thoughts. What stood out for you? What you have an objection to? I would love that feedback session from the room.
I feel like isn't the whole point, or at least like the direction of the long-term adoption for agents, especially the autonomous ones, just the idea that we can scale compute faster and scale deployment of compute faster than we can scale alignment. So that you can kind of like brute force that. Interesting. You know what I mean? So like in a sense, the organization's complete output isn't the sum of all this. It's more like, okay, but this week over these 3 days while we're experimenting with something, everyone goes in different directions. After that, we're going to throw away everything else. So we literally throw away all the factors that like pointing in the wrong direction. It's like, okay, we figure out this one method that works really well. This new technique, this new Asian IDE that everyone's using, okay, everyone's going to adopt that, okay, scale that.
So if I understand correctly, forget about those people, which is all agents, right? And then you're saying at any given moment in time, you sample a set of different initiatives, you scale different ones, you then throw money into at it, and then in a way then you have to sort of filtering function 1 week later or 2 weeks later and figure out which ones work and which ones didn't. Right?
So it's bounded by time and then that limits the damage.
Yes, exactly. And then that's the idea. I think that's slide I want to do it quickly. If you think about it, you have, in a way, if I understand correctly, you're running a genetic algorithm to the process. You're saying, hey, I'm going to spawn a whole bunch of different agents, the ones that work, right? It's aligned towards some objective, which is making money.